Welcome to the SEI Podcast Series, a production of the Carnegie Mellon University Software Engineering Institute. The SEI is a federally funded research and development center sponsored by the U.S. Department of Defense. A transcript of today's podcast is posted on the SEI website at sei.cmu.edu/podcasts.
Welcome to the SEI Podcast Series. My name is Suzanne Miller, and I'm a principal investigator in the SEI Software Solutions Division. Today, I am joined by my friends and colleagues, Jerome Hugues and Joe Yankel. Jerome is a senior architecture researcher, and Joe is a senior engineer, both of whom work with me in the SEI Software Solutions Division. Today, we're here to talk about their work with ModDevOps, which is an extension of DevSecOps that embraces model-based systems engineering practices and technology. And I'm very excited about this because I love the conjunction of these two concepts. So I want to welcome both of you, and let's get started by talking about why are you here? What brought you to the SEI? Tell us a little bit about yourself and the work that you do here so we can get other people excited about coming to the SEI. So Joe, why don't I start with you on that one?
Thanks for the intro, Susie. I came here to be part of this ecosystem, really learn, expand upon what I learned in industry with software development and testing, and help apply that to our DoD partners.
That I think is a unifying thing for many of us is DoD, DHS, the sort of government partnerships that we have. Jerome, what about yourself? Where do you come from? And you're not from Pittsburgh, are you?
No, I'm not. I'm not a native from Pittsburgh. Native from France, as you can hear. Well, actually, before joining the SEI, I was a professor of software, computer science in general, with an emphasis on model-based and safety-critical systems. And so 15 years ago, I started working on this AEDL technology, and I became an expert in Europe, and I got the opportunity to move to the SEI, not Pittsburgh. Actually, I'm working from the Arlington office, and applying model-based techniques to the very challenging problem from the industry on this side of the Atlantic was a very great challenge, and I was really impressed by the type of challenges that we have to address on a daily basis. And as part of my work for the SEI, I'm still working on model-based, working on AEDL, and working on making all the ideas that we have on model-based transitioning to the industry and customers that the SEI is supporting.
And for those that don't already know, AEDL is Architecture Analysis Design Language, which is one of the implementation strategies for model-based engineering that the SEI is very involved with. So just to clarify that for people. So, all right. So mod in ModDevOps stands for model, right? So let's talk about how does adding model-based engineering change the way we think about DevSecOps? What is it about model-based engineering that we're adding into the DevSecOps pipeline? And Jerome, why don't we start with you on this one?
Yeah, actually, it's going in both ways. From my perspective, I am extending MBSE, model-based systems engineering, with DevSecOps. Okay. And on the other end, we can also do quite the opposite, extending DevSecOps with model-based. And it's really a question of perspective and play on words, if you will. From my perspective, coming from the MBSE community, coming from SysML, AEDL, and others, when I do modeling activities, when I create my system, I start from the abstract and I go down, refine my models, and at some point I will start implementing it. And as I'm doing that, I, of course, benefit from early analysis that we can do on models. But also at some point, I want to go to the implementation. And this is where the connection with DevOps or DevSecOps is relevant, because DevSecOps will allow me to go further into developing my system, implementing it, and getting back metrics on my system so that eventually I can reflect on my design. And so that's really one way of combining things, extending MBSE with DevSecOps. And Joe probably can give the opposite extension, which is you are the expert on DevSecOps, and how do you benefit from models?
I think you said it correctly. We understand these best practices that DevSecOps gives us, but what it really lacks is a formal method to understand the needs of the ecosystem, right? We know we can gather data well. We can monitor that data. We have metrics. But to really capture those things. You have to formalize it via a model. The model can go much deeper. It can help an organization not only understand requirements, capabilities, but even the organizational roles that need to be in place to do these activities. So it's a very powerful tool.
One of the things that Fred Brooks, many of us know him from the Mythical Man Month, but he's also the author of a book called Design of Design. I'm paraphrasing, but one of his statements is along the lines of, you can't really understand a design until you start to implement it. And both of you are talking about that from different perspectives. I can't understand my model until I start seeing what happens to it when I actually implement pieces of it through a DevSecOps pipeline. And Joe, I can't really understand my design until I have a model that I can use as a reference point for understanding if what I'm measuring and monitoring actually has any value or meaning. So this is an evolution of this idea that we need to implement to understand design, but we have to do enough design so that we actually can implement something that's meaningful. And that's what's got me excited about this extension of these two concepts, or the conjunction of the two concepts as we go forward. Because
Susie, to elaborate on that, there is something relevant. You mentioned the Mythical Man Months, and everybody is concerned about how many man months does it take to implement a system. And in both MBSE and DevSecOps, we advocate a lot for automation.
Yes.
With the model, we can do early analysis. The model is not perfect, but you can already remove a collection of risks. This is what the SEI has been doing, for instance, with AADR that you mentioned and AgVIP, this architecture-centric virtual integration process. When we have a model, we can also perform some code generation. We can do a lot from, everyone knows Cade, Simulink, even AADR code generation practices. And when we start doing that, we can go further and say, okay, the code that we have generated can be part of the DevSecOps process that will kick in after that, so that we can go further and, more importantly, faster into delivering the system. And so this aspect of automation means that, of course, we still need actual human months, but there is a lot of human months that actually get shrinked thanks to automation.
And we turn the Mythical Man Month into the Mythical Man Hour.
Oh yeah.
Yes. So that's a goal for a lot of people is that fast information. And one of the things I'm seeing as we have more connection between software and physical systems, what we call the cyber physical systems, when you make decisions in hardware, they are more difficult to change later on down the road than the software. And to the extent that we can do better models of our hardware and that aspect of hardware design in these cyber physical systems, we get better data to make those hardware decisions at a time when we still can afford to change our minds. And in some of the systems I work with, that's actually very important. That's one of the most important things about modeling, is that we get information that we need so that we can make better hardware decisions before they're too late to change. Okay, so I've actually answered one of the questions that I have for you, which is, what is some of the value of working in a digital engineering environment that applies MBSE? And what kinds of things, besides what I've already talked about, does it make possible that can't be accomplished in more conventional environments? And Joe, I'll start with you this time.
All right, I'll take a crack at this one. So what I see happening today is we're playing that game whack-a-mole, right? We're seeing a problem, we're responding to it. We often throw a tool at it. Modeling can really help us here, right? It formalizes these planning activities that have to occur, right? We talk about the actual requirements of the system from all the stakeholders, right? The DevSecOps says we're going to collaborate with everybody, right? So I really need to know on the hardware what kind of things it does, right? If we're talking about measurements, well, I might affect how we measure that hardware, right? We have to have a system capable of capturing those things. So we're not only concerned with the application or system, right? We're also concerned with the system that enables the development of system, right? So the system of systems, so to speak, multiple pipelines.
Sure. That's
very complex if you don't formalize your approach. And a model is about this, right? It allows us to look at all the requirements. We have a good idea of what DevSecOps is, but we need a source of truth, right? A model can provide the source of truth that here's all the goodness. Here's how we are addressing security. Here's how we're addressing what the maybe the core pieces of DevSecOps is. We need to do those things, and we need to quit doing them in silos, right? So even us have recognized that there's a lot of great practices. How do we combine those and build upon them? Yeah. We put them in a model, right? It'll enable the future resilience that we really demand.
And I'm hearing you talk a little bit about quality attributes, right? Which the SEI talks a lot about, that the quality attributes are elements that go across different silos of a cyber physical or just a cyber system. You know, security and usability, sustainability, you know, all those things that make a difference in the overall product, but can't be captured in any single element of the product. And models allow us to see the effect of changing a security attribute. If we loosen this up, you know, what happens? And models allow us to look at that, and the DevSecOps allows us to test it and say, okay, let's try that. Let's see what happens with the code if we do that, and monitor and, you know, run our simulations and all the rest of it. So that aspect of modeling is, I think, something that a lot of software engineers may not think about in terms of how it enables them to actually achieve some of the quality attributes that they sometimes kind of throw their hands up and go, well, I can't implement it in this one component, but it affects all the components. What else would you want to say about you know, working in digital environments and how it sort of makes it easier for the system and software engineers to accomplish their work, Jerome?
Well, before that, perhaps, Susie, we can just remind a little bit how we came to the definition of ModDevOps. Really, we, as Joe and I and others in the team, we wanted to define it really as an extension of DevOps and DevSecOps. And so basically we change, or we act, if you will, the DevOps definition as provided by the Air Force, so that we can just change a couple of words, saying that really ModDevOps is a system software co-engineering culture. And it is really this cultural aspect that Joe mentioned before. We have a collection of stakeholders. They have to interoperate, to work together to achieve a common goal. And for that, we'll use model and as a support to some DevSecOps activities. We, as we were working on this project during FY20, what we did is not only models of the system, but also models of the pipeline that will go from model to the actual system. And it is really this aspect that can help a lot digital engineering activities. Think about the system you want to produce, but also how you want to produce it, how you want to collect all the quality attributes. Some of them will be evaluated on models. Some others will be validated on the implementation. Some others will be validated on the final deployed system. Having a clear picture of where you get those information, how they can be combined, so that ultimately you can convince the customer that, yes, I have done my duties, I'm delivering the right system, and I can demonstrate why the system will work as expected. By collecting all those data across the complete system lifecycle between engineering and production and deployment is really the greatest value we can get, which is really to understand what is the system, how we build the system, and why we believe the system is correct.
So you're basically describing enlarging the ecosystem. Joe talked about this earlier, that there's a whole ecosystem around this, and you're enlarging that ecosystem. So my challenge to you is to take on the next evolution of that ecosystem, which is digital acquisition, right? Because you're talking really, right now, we're really talking about the engineering part of the system. But around that is all the things that go into how do we decide what the right system is, and how do we get the right people to build that system, and how do we get all those stakeholders to agree on what the quality attributes are. So that's you know, for the next 6 months or so, you should be able to just knock that out. And I'm teasing a little bit because that is actually the next step, and we're seeing you know, programs that are trying to embrace digital acquisition. But my assertion would be you got to deal with the ModDevOps from an engineering viewpoint first, so you understand that ecosystem before you can really understand what the next level of that ecosystem is. So anyway, all right, let's go on to getting in. We've been really up in the clouds with this in terms of ecosystems and things. Let's talk a little bit more down in the weeds about what would be the typical steps in a ModDevOps development process, and what steps in that process would be different from what you would expect in a typical engineering process that results in a piece of software. Who wants to go first on that one?
Well, probably let me start with that. Probably surprisingly, I would say that we won't change a lot of the steps themselves. Simply what we will change is what we do during the step.
Okay.
Basically, of course, we have to plan. What do we want to do? What are the requirements? What are the properties or the quality attributes that we want to collect? What are the parts of the system? How do we want to engineer them? And how do we integrate them so that we can deploy the system? So it's basically typical DevSecOps steps that you will want to perform. What will be different is really to consider at each step what benefit you can get from models. So, of course, when you start very early, requirements, well, you can do requirements with SysML, you can do requirements using doors, you can do requirements on a chalkboard, if you will. But you are starting populating a database with quality attributes that you will collect and connect to the other steps. When you start thinking about the architecture of your system, when you start thinking about the quality attributes, when we did this TwinOps project that supported this activity, we took the example of a cyber-physical system. So we started with the big picture, SysML. What is my system about? And after that, we refined it. We want to build an actual software-hardware system. So obviously, we will need AADL for that because it has the right level of semantics for that. And after that, you gave the example with the connection to physics. We had two options. Basically, we could prototype it on Raspberry Pi, which is great, but we would have needed thousands of them for a complete large-scale IoT systems. On the opposite, what we decided is to use Modelica, which is also a modeling notation, in this case for physics. And after that, when you have all those models, the first question is, why? How do you interpret? How do you integrate all of that? And again, through model-based techniques, we can make them interpret. We can generate code from AADL, we can generate code from Modelica, and we can integrate to build digital twins. And we have demonstrated the feasibility of that through this virtual integration approach that we are promoting through model-based techniques and code generation from models. And after that, we apply the other steps of DevSecOps, which is, okay, we want to have CI/CD techniques, we want to have automated deployment, we want to have automated packaging, and we want to collect data. So it's basically DevSecOps with a little bit of models, but the models that we have built have been selected because of the problems that we wanted to resolve, which was a CPS, and therefore AADL and Modelica were perfect fit for that.
Did you want to add anything to that, Joe?
I think Jerome said it right. Some of these DevSecOps practices helped enable the repeatability of this, right? Core concepts like infrastructure as code, configuration of code, and what we talked about, right? We want to do this early. We want to prototype. So this is really all about shifting left, failing fast. We don't have to have the model perfect, but we have to begin doing these things to improve it continuously. So in our minds, we can't have a model that goes through iterations. And we want to make sure our system can support those types of improvements. And if we do it early enough, we have a lot of confidence we can do this later, right? So sustainment, maintenance, we're addressing those things now, not in the future.
Yeah, and your analogy, I mean, you mentioned a lot of DevSecOps is concentrating on something as code, infrastructure as code. But if you take it to the model, because we can generate code from model, and this code can be integrated, to some extent you can have model as code. And to me, model is nothing but, I would say, a more abstract notion of source code, to the point where you can say for some classes of system, you can have a system as code, which is a little bit, I would say, shocking for some systems engineers to think about it. But for the class of CPS that we are working on for IIoT systems, for many, I would say, even IT systems, there is no real difference between the system itself and the code or models representing it. And so thinking of system as code is really one of the results that we have demonstrated as something tangible through this TwinOps project. It's really a proof of concept, demonstrating that, yes, it is achievable. And now the key question in terms of transitioning that is really, okay, it worked on a small scale example. How could it scale at the enterprise level for the DoD? That's a gigantic challenge ahead of us. But from what I have seen, I'm definitely convinced that it is something that is achievable through digital engineering and digital threads initiatives.
So one of the things that comes up in that for me is many of our viewers may know that the DoD did initiate a digital engineering initiative in the NDAA. I think it was 2018. I'm not exactly sure the year. But so there is, if you're in the DoD, there is leadership support for moving towards digital engineering. One thing that we haven't talked about is the difference between applying this in a new system being built versus applying it to legacy systems. One of the challenges that we know about legacy systems is creating models is essentially a re-engineering process of understanding what is in the current system so that you actually can start to interrogate it and start to ask questions about it. Is there work going on in that aspect? Because the project that you guys worked on was more of a new set of requirements. It wasn't a legacy system that was being built. Can you speak to that, just so for our viewers that sort of are in the legacy environment, they have an idea of how this might apply to them or might not?
Well, I can just say a couple of words on that. So if we take aside ModDevOps and if we look at what we have done with AEDL, in the past, some members from my team, the ModelBased team, took existing systems. We did a little, well, not we, they did a little bit of reverse engineering to demonstrate specific attributes, like, for instance, a capacity to change the CPU architecture without impacting the scheduling or the real-time properties of the system. So the question really depends on the type of question you have. Of course, the more precise the question, the more work you need to do these reverse engineering activities. But from a model-based perspective, really the question is to recognize which question can be answered through this reverse engineering effort. And you're right, at some point, the cost of modeling is so high that redeveloping the system is the only option. The same way that when you take legacy software, there is a trade-off between recompiling it for a new CPU platform versus redeveloping it. We're exactly in the same situation. It's really a trade-off, and we have to collect metrics to know what is the decision point. We are not really at this stage yet in the MBSE community, I would say.
That's fair. Joe, anything to add on that topic?
Well, you hit on an important topic that of it's harder with a legacy system, right? There's a lot of considerations. I do believe since we've done this project, we've also looked at just modeling what DevSecOps is just by itself. Like, what is these core attributes? Can we define it as a model? Now, this approach, this would allow you to evaluate a legacy system to understand what capabilities it may lack, right? So you could use modeling to help pinpoint places of prioritization, right? Places where, this is a great practice, we're not doing it, let's focus on improving it here. And so it can be done, it's going to have to be done with legacy. Certainly some things are easier. Some architectures are simpler to do this with too, right? So complex systems of systems is a challenge. We do know this. If you started with model-based, it will be easier to proceed and update. Retroactive fitting of this is a challenge, and it has to be evaluated on a per system basis.
Sure. So one other question, you brought up sustainment, and one of the things I know is an issue in model-based engineering in general, and I'm curious as to how you see it when you bring DevSecOps into it, is the issue of keeping the models up to date. From what you've said so far, my impression is that this is actually easier if I have modeling as part of the DevOps pipeline, because I'm going to have some feedback loops that lead me directly back to the models themselves. Can you comment on that in terms of how ModDevOps as a strategy improves your ability to keep the models up to date and relevant?
The interesting aspect, if you apply this idea of a pipeline that we inherit from DevSecOps, is also that with this pipeline is coming, I would say, a list of responsibilities, the who is who of the project. I am in charge of the CI/CD. I am in charge of defining requirements. I am in charge of defining the metrics. And you can apply it also in the models. I am in charge of defining the architecture. And beyond those responsibilities, there is a collection of models. And so from the metrics, you can identify which portion of this pipeline has to be updated. Do you have to update something in the software model, on the architectural model? I mean, it will be a discussion between those experts. And definitely the benefit is that because we have also captured the process, we have captured the complete pipeline, we know exactly who is in charge of what, so that we can do an impact analysis, so that we can put around the table the right set of people saying, okay, we have this issue. Who is in the best position to address it? Are you the software guys, the architecture? They can have this discussion and know precisely how to react, I would say.
Joe, anything to add to that?
I'd say he nailed it there, right? We have this with a model, we have operational process flows. These include the planning sessions, right? Part of planning is saying, how are we going to look at the data we've decided matters to us, right? So you plan the metrics, you plan the data that could influence the model. So some of this data as part of these sessions will be, we're not performing well, or something's happening. We need to update the model based off this information. This is continuous feedback is useless if you don't have continuous evaluation of that data. And that data can potentially affect the system itself, or it could affect the system that builds the system, or that enables the development of that system, right? And so definitely, if anything, the model could help enforce, this is how we operate. These are the process flows that continue through the end of time with the system.
We're getting to continuous evolution. We've got continuous integration, continuous deployment, and now we're moving into continuous evolution. So we've got I, D, and E.
Yeah, and actually there are two continuation to this idea that you push, Joe, which is to remember that we have this feedback loop, but as we are doing models, in addition to implementation work, we can have actually as many subset loops as we want. For instance, I can have a subset loop between SysML and AEDL. SysML will give me the overall architecture, and I can propose and evaluate multiple designs. And we can reject one because it is too costly, because, well, a few dollars a board can make a big difference. Or the energy consumption may not be the right one, or the interfaces may not be the right one. And so we can have this small micro loop. And we can have another one, for instance, that we experimented a little bit between AEDL and Modelica for representing the sensor, or what type of metrics do you want to collect from the environment, the temperature, the pressure, etc. And so this idea of CI/CD is not something, I mean, we should not reproduce a waterfall model between the top level SysML and the final system. We can have as many intermediate feedback loop as we want, thanks to automation, and it can happen anytime we have two models that are exchanging engineering information, or even within one model. And that is something that is also striking, to think that we can automate and define as many intermediate pipelines as we want. And that is also a great added value of this approach.
So I'm hearing two things. One, the pipeline is itself a model, and we can keep evolving that model as we get data about the pipeline. And I'm also hearing the model as a pipeline. I'm hearing both sides of it, right? The model shows me the pipeline, helps me to make decisions as we go along. So what we're really talking about here is a different way of doing decision making in engineering. And I am hoping that our viewers are just as excited about this as I am. And so the thing I want to close our discussion with is, if I'm somebody who's excited about what I've heard here today, and I'm working on IoT, cyber physical systems, any complex software development. Where do I find out more about this? Where should I start? What resources are available to me through the SEI or other sources so that I can actually get started doing something with this? And I'll start with Joe this time.
All right. So the SEI does publish some resources, right? We can, through those papers and the publications we have, you can reach back to the SEI to get additional information. Our current research, I don't believe that's all public, but we're still currently researching this, right? This is a difficult effort, I would say. It's ongoing, but we do expect to have some public releases of some of the DevSecOps modeling we're doing now. It's going to need your feedback. So, we'll appreciate anyone that's interested in to give us that feedback so we can make it right. We also think this should be we want to fail fast here. We don't think it's going to be perfect. But we want to get there by putting it out there, trying it. That's one of our goals. Let's prototype, let's build, let's test, let's get better.
What about some resources in the modeling, Jerome?
In terms of modeling, we have a lot of resources in the digital library at the SEI on this topic. There is a technical report also on TwinOps that will be available also at the time you watch this video. And generally speaking, ModDevOps, as we introduced it, is really a philosophy much more than a collection of technologies. So let's discuss on that. That's really probably that, in my view, probably is the best approach to exchange and see how it applies to your specific problem. And the more problems we can discuss with you, the bigger we can refine all those concepts, because we really believe that there is a big push towards this direction, but it will take a lot of time to have an enterprise-wide agreement, I would say, across the complete industry. But we strongly believe that there is something very important to look at for the future. And so, and in terms of activities, continuing applying also some of those ideas, trying to improve the semantics of some models, but that will be the topic of a follow-up discussion, I guess, Susie, in a couple of months.
Absolutely. More discussions. I love these kinds of discussions. I do love these kinds of discussions, and I want to thank both of you for being with me today and letting me take you far afield of probably where you thought you were going to go with this discussion. But I think it's so important. This is such an important topic, and it really is part of the future that we're looking at. It's not just about, artificial intelligence. It's about being intelligent about how we do the work, and modeling the work is one of the ways we get more information about doing that and iterating. It just, all the things come together for me. So you can tell I'm excited about this. So thank you again for joining us. Thank you to our viewers. We will include links in the transcript to resources that were mentioned during this podcast. And there are a lot of, if you start looking at model and DevSecOps, you will find a lot that are very compatible when you start looking at the work of the SEI. So I encourage you to go out and do that. Thanks again for joining us today.
Thank you.
Thank you.
Thanks for joining us. This episode is available where you download podcasts, including SoundCloud, Stitcher, TuneIn Radio, Google Podcasts, and Apple Podcasts. It is also available on the SEI website at sei.cmu.edu/podcasts and the SEI's YouTube channel. This copyrighted work is made available through the Software Engineering Institute, a federally funded research and development center sponsored by the U.S. Department of Defense. For more information about the SEI and this work, please visit www.sei.cmu.edu. As always, if you have any questions, please don't hesitate to email us at info@sei.cmu.edu. Thank you.